All right, folks, here we go. So we're working on section 5.5, triangle inequalities. Triangle inequalities. So first thing we want to take a look at here is the theorem that says the sum of the lengths of any two sides of a triangle is greater than the length of the third side. So you can see what that looks like. So if we're looking at AC, side AC, these two here have to add up to be bigger than the side. Otherwise, it does not form a triangle. So you really only need to check the two shorter sides to see if their sum is greater than the longest. So that right there is going to determine whether we have sides that will actually make a triangle or not. So in this example, two smaller sides are 2 and 4. Is 2.4 great? Is 2 plus 4 greater than 5? Is 6 greater than 5? Yes, so now we can form a triangle. Is 6 plus 8, and again, sometimes they don't order it for you, so you have to put them in smallest to biggest. Is 6 plus 8 greater than 14? No, that does not form a triangle. So that's how we're going to start here, and then we have the same concept that we just finished on the other slide. Two sides have to be bigger than the third. So the first thing we do is says, is it possible to form a triangle with sides, and if not, explain. So take the two smallest, and again, this is not in order. So what are your two smaller sides? 5.1, 6.8. So I'm going to add those two together. Is 5.1 plus 6.8 greater than 7.2? Okay, well, we get 11.9 greater than 7.2. Final answer is yes. Final answer is yes, and I would move on from there. You got to just only have to check the smaller ones. So again, is it possible? What are your two smaller sides? Here we go. 8.5 plus 11.5. Is that greater than 20.5? Well, the answer to this case is this is 20. Is 20 greater than 20.5? No, will not form a triangle. Again, same idea, same concept. Here's your two smaller ones. 4.8 plus 12.2. Is that greater than 15.1? Okay, so when you add those up, are they greater than 15.1? So we get 17 greater than 15.1. Answer to that is yes. We'll form a triangle. So this one right here, it says, now we're flipping to a different idea here. It says which measures cannot be YZ. So you're using the same concept, but now we're trying to decide what is a range of values for sides. So what we want to do is this. So this is what the book does. I will give you the answer, and then you can decide which method you want. They did that as a multiple choice, and they did this, and that's how we're going to write our answer. But let me tell you how I would solve this problem. So you have 8 and you have 14. So x plus 8 has to be greater than 14. X plus 14 has to be greater than 8. And 8 plus 14 has to be greater than x. So I set up these three inequalities. I solve these inequalities. So what I mean by that is I subtract the 8, and I get that x is greater than 6. So x has to be greater than 6. When I subtract this 14, I get x is greater than negative 6. You can't have a negative number, so we're not going to work with this one. That one will not even, we won't even use it. But then the next one here is 22 has to be greater than x. So what that means is now we have two statements. We have two statements. You put x in the middle, put the bigger number to the right, smaller number to the left. So x, use a symbol, has to be greater than 6, and x has to be less than 22. So any number in that range will work. And then again, if you don't believe me, test it. Pick a number that's in the range. Let's say that x equals 10. Okay? So if we're using the same concept we did before, so we have 8, 10, and 14. Using the prior example, add the two smaller. Is 8 plus 10 greater than 14? That would be yes. So that's a range, and I found a number in the range. Let's try a number not in the range. Let's say we chose 3. So if we did 3 8 and 14. Let's say those were your three numbers. What's 3 plus 8? That's 11. Is 11 greater than 14? That is no. So that's a number that's not in the range. So that tells you that's why those numbers don't work. So we're going to try that concept here. It says which measure cannot be PR. So again, how would I start? X plus 5.2 has to be greater than 7.2. X plus 7.2 has to be greater than 5.2. 5.2 plus 7.2, that has to be greater than X. Okay, so then how would we add these? Subtract over the 5.2. So I have X is greater than 2. If I subtract over the 7.2, I have that X is greater than a negative 2. That one don't work. We can't have a negative. This gives me 12.4 is greater than X. So now I write my range. I put the highest number on the right. So if I go up here, put X in the middle, I put 12.4 over here, and I put the 2 over here. X has to be less than 12.4 but greater than 2. Which of these numbers in this group are not in that range? 13 is not in the range. So the final answer to that question is 13. Next slide, same concept. Which measure cannot be X? And then the last question part of this says find the range of the perimeter. So we want to do the same thing we did there. So X plus 6 has to be greater than 9. X plus 9 has to be greater than 6. 6 plus 9 has to be greater than X. So what do we get? Subtract this over. X is greater than 3. This one you subtract over, you get a negative. Can't do that. And then the next one here, we're going to get 15 is greater than X. So again, let's write our range. Let's write our range. So X in the middle. Highest number to the right, 15. Lower number to the left, 3. X is less than 15. But greater than 3. So that is our range. So if we look at the range, which measure cannot be? The answer here is 16. Second part of this question, though, is the next thing we're going to ask is find the range of the perimeter. So if you think about it for a minute, it says xy is 6, and yz is 9. So that is two distances that we have. We want to find, and that we just found this range of the third side, which is right here, that we already have. That's up top here. So what they want to know is, what if they wanted the perimeter? Find the range of the perimeter, okay? Well, if you think about the range, what distances do we already have? You already have 9 plus 6. What's 9 plus 6? That's 15. So if you take 15 and I add 15 to both of these numbers, that gives me a new range. X is less than 30 and X is greater than 18. That right there gives me a range of my perimeter. My perimeter will be between 30 and 18. So if we wanted to find the perimeter, that's the next step in the process. So here, same idea. Find the possible lengths for the third side and then find the range. So again, I'm going to go X plus 5.2 has to be greater than 7.2. X plus 7.2 has to be greater than 5.2. And then 5.2 plus 7.2 has to be greater than X. When we do that math, we find that X is greater than 2. This one gives us the negative. And then this right here, we get 12.4 has to be greater than X. So again, here is our possible range. So X in the middle, higher number to the right, 12.4, lower number to the left, that's 2. This is our range of values. Again, now if we want the perimeters, you have to add those two together. So we already have 7.2 and 12.2, and 5.2. So we're going to add 12.4 to both of these. So our range for the perimeter is x has to be less than the 24.8 and greater than the 14.4. So that right there shows you that is our range of values. And this was our answer that we have here. That's a range for the perimeter. Find a range of possible measures of x if each set of expressions represents measures of the side of the triangle. Find all options, then the final. So again, same concept here. X plus 1 plus x plus 2 has to be greater than x plus 5. So we can solve that, and then I'm going to, let me just write out all three first, and then we can solve those. So x plus 1 plus x plus 5 has to be greater than x plus 2. And then the last one here, we have x plus 2 plus x plus 5 has to be greater than x plus 1. So now we can solve these. That right here is 2x plus 3 is greater than x plus 5. You subtract over, we get x is greater than 2. X is greater than 2. This equation right here, we have 2x plus 6. 2x plus 6 is greater than the x plus 2. Subtract over, we get x is greater than, this one we get a negative here, we get a negative 4. So again, we're not going to deal with negatives. And then we have, next slide here, we have again 2x plus 7 is greater than the x plus 1. If you subtract over again, you get x is greater than negative 6. So when we evaluate the final answer here, we are looking for x is greater than 2. So it says show all options, and then we want the final. So if we are allowed to include negatives, we would go with x is greater than 2. Again, if these are side lengths, find all the sides. So we have to find value that is greater than 2. So we need to find a number that's greater than 2. This slide here I want to go through real quick just to a perpendicular segment from a point to a line. The shortest distance between two lines is a straight line. So if we wanted a distance from AB to P, we would have to use a straight line distance right here. Shortest distance is a straight line. Same with this one here. Great job, folks.